transforming data into information. We will be introduced to factors driving the need for machine learning to transform large sets of data into information that can be used to make smarter decisions. Using a few day-to-day examples, students will learn how all our lives are being touched by fusion of several exciting and emerging fields of technology such as machine learning, artificial intelligence, and big data. Let's consider the question, why machine learning? As we discussed in the previous module, that is Module 1, we need three main components to enable intelligent manufacturing framework. First, sensors to collect data. Second, a data acquisition and management system to process and store data. Third, machine learning and knowledge discovery component to process the stored data. We spoke about components number 1 and component number 2, which is sensors collecting data and signal processing in the previous lessons. Now, let's discuss how the output of signal processing can be used by the machine learning and knowledge discovery component to make decisions. In this context, we will introduce the concept of machine learning. To understand the concept of machine learning, let's consider an example. You may have used Netflix to watch your favorite movie. You log in, search for a movie title, then select a movie, and you watch it halfway or in full. Then you sign out and go about your daily life. Once you log back again into Netflix system, have you noticed that the system gives you a list of recommended movies in a singular genre to the one you have watched previously? How does that occur? The system uses data from all previous system uses, and learns about our likes and dislikes, and makes prediction based on our past uses of Netflix. This is an example of machine learning working in our daily lives. In the Netflix example, some features used to make predictions are the age of the user, genre of the movie, and movie actors. Features are a salient way to abstract and represent data that are useful to make predictions. There are several other examples of machine learning in action in our daily lives. For example, social networking profile recommendations features of LinkedIn and Facebook uses machine learning. The online shopping recommendations in Amazon and eBay are enabled by machine learning. The machine learning is also pivotal in implementation of automated office assistants such as Apple's Siri and Google Assistant. In general terms, we can explain the conceptual working model of machine learning as follows. Machine learning focuses on the development of computational models that can teach themselves to learn patterns or models from existing data and utilize the learned model when exposed to new data. In the Advanced Analysis course, we spoke about big data, high volume of data of wide variety being generated at high velocity, the 3 V's of big data. Machine learning systems search through big data to learn patterns in the data and use these patterns to make predictions or recommendation in light of new data. Practical uses of machine learning. Building on the concepts outlined in the Lesson 3 on machine learning, this lesson will delve into the uses of machine learning and sensing. How machine learning is creative, disruptive innovations in the smart manufacturing domain, thereby enabling extremely useful application in digital manufacturing and design domain like within systems for automated high-speed quality control and product classification using the digital thread. Pay attention to the following example that illustrates the uses of machine learning in industrial setting. Sensors and machining centers are helpful, so we want to have machines know where the parts are in the machines. So, they'll have to probe a part, love to touch off a part, and after knowing where that part is in space, sometimes, it'll be touching off on fixtures or the part themselves and know where that is. So, those sensors are important. Other places sensors are used to detect broken tools. Before machine program runs, we want to make sure that we're not going to be making scrap parts when the machine may be making hundreds or even thousands of parts. So, that the sensor will check to make sure that the tool is present and not broken before the machine later on. That sensor communicates back to the machine and qualifies the run for us. In addition to intelligent machine sensing, machine learning can be used to enable various advanced manufacturing enterprise functions. For example, in the optimization of the overall supply chain. Over 70% of many manufacturing companies' products are sourced from the suppliers. Using machine learning, suppliers and buyers collaborate effectively to reduce stockouts and meet customer delivery dates. In predictive maintenance and repair applications, machine learning can be used to predict the servicing and repair times of machine based on user pattern of the machine. Machine learning can also be used to increase production yields. Aerospace, defense, And other high-tech manufacturers today are using machine learning techniques to increase production capacity to do quality control and forecasting. Wow,